Okay, hi and welcome to some video notes on 3.6, which for us is going to be solving absolute value equations, and then we'll visit inequality shortly thereafter. So, three basic steps to solving an absolute value equation. One, you got to remember that you're going to solve for the absolute value if that's not already done. The examples we'll see in this first set, well, those will be done for us. Two, we have to be able to remove the absolute value. We've got a way to get the stuff that's inside the absolute value outside of the absolute value so that we can solve. You'll find that our variable, most often for these, will be inside of the absolute value. What does that mean to do? Well, you got to remember that absolute value is a distance without signs. So there can be a left distance and a right distance from whatever location that we're talking about. So we have to take that into account, and the fact that when we remove something from inside the absolute value, that we have to address both the negative and positive version of that. So to remove them, we take it out, whatever's inside the absolute value, and we make that quantity negative and we make it positive. And we solve both. And that's how we deal with removing the absolute value. After that, we're going to go ahead and solve both of those new equations, because we'll have two, one negative, one positive, and whatever the result is, that's our solution for the absolute value. Remember, one key thing is that our absolute value does work with the same solving operations that we're used to, mainly with linears and all of our polynomials that we've been working with. Okay, let's get right down to it. On this first example here, it says solve this solution here. So we've got the absolute value of x equals 3. This is a pretty basic one. We're still going to address the fact that it's positive and negative by taking, and I like to do these arrows to show me that I'm dealing with the absolute value. After I do these arrows, once for a negative value, what's inside, and once for a positive value, my absolute value is done. At this point, I won't write it again. So I'm going to go ahead and write negative, and I'll put it in parentheses, x equals 3. That's my negative portion of the absolute value. And I'm also going to have a positive portion. I'm going to not need the parentheses here because there's a positive one being multiplied, so really I don't need to show it. So this looks pretty easy to do. How do I get rid of a negative x? Well, I'm going to go ahead and multiply the whole thing, this whole equation, by negative 1, which will reverse all my signs, and I'll be left with x equals negative 3. And this one over here, x equals 3, is already solved for. What does that mean to do? Well, visually, this is what it means. An equality means that we've got a point included at negative 3, and we have a point included at 3. That's the excitement. 2 points we got out of there. Two distances of 3, one in the negative direction, one in the positive direction, and we're done. Let's see another example. All right, looking at this example, you'll notice that we've got a new contender here. We've got a negative 3. So if you recall from our notes, solve for the absolute value first, then remove stuff. So you can't remove until everything's gone from the absolute value. It's almost like you're isolating the absolute value first is one of your main goals. So let's go ahead and move this 3 then away. So I'm going to be left with the absolute value of x equals 8. At this point, I'm going to go ahead and remove the x, as in a negative version and a positive version. Now I will not write the absolute value after this, so I'm going to be left with a negative x equals 8, and I'm going to be left with x equals 8. Again, multiply this whole quantity, this whole expression, by negative 1, and I'm going to find out that x is equal to negative 8, and of course the right side is already set up and solved for. So x equals negative 8 and 8. So if I come down to a number line, what does that look like? Again, I'm going to have a solid point on negative 8 and positive 8. Sometimes we'll receive different values or different terms inside the absolute value. Most often that'll lead to different solutions, meaning that you've gotten conditioned that we're getting the same value out of the absolute value. I don't want that to become a pattern for you. So you'll see that we've gotten the same value, one negative, one positive. I guess I should say that would be the correct way. But when we have different values inside, we can get different solutions out. So they might not be the same value with a negative and a positive. Don't make that a thing. We're going to do the same thing. Our absolute value is isolated, so we can go ahead to remove then our absolute value. One negative version, one positive version. The whole expression of x minus 3 must become negative. Do not just make the x negative. That is a common mistake. Okay, and we get the quantity of x minus 3 equals 6. Oops, I forgot to write my 6 there. There we go. So we've got this. Again, I don't need to put parentheses around it because it's going to be multiplied by a positive one, where the left side is going to be multiplied by a negative. So doing that, I could distribute. However, since I'm solving for the x, I'm going to go ahead and multiply this whole thing by negative 1, and that's going to remove that sign. So I'm left with x minus 3 equals negative 6. I can finish solving that by adding 3 to both sides, and so I'm going to find out that x equals negative 3. And I have to solve the right side here. So I'm going to go ahead and add 3 to both sides. I'm going to find out that x is equal to 9. So notice this time I have two different solutions. I have a solution at negative 3, and I have a solution at 9. All right, thanks for watching this portion of the video. In the next set of the examples, you're going to see some operations where we have to clean it up, and there's going to be some multiplication and division.